Good afternoon. Today we are going to discuss about Black 2 groundwater exploration. Yesterday we have discussed what is the hydrogeological uh, processes, okay, and what is aquifer, what is confined aquifer, what is unconfined aquifer, what are the aquifer properties, and what is porosity, permeability, Darcy's law we have discussed, okay. And today we will discuss about the groundwater exploration methods. Okay. Here you can observe. Here you can observe water is a vital for development and industrial growth, particularly where surface water is scarce. Okay. And growing population and demands for irrigation, domestic and industrial use have strained water resources. Groundwater exploration is essential for effective and sustainable water management. Okay. And proper exploration techniques are crucial for from a source location to well design and construction. In groundwater exploration, we'll discuss about the how to identify groundwater potential zones and what are the methods involved in the groundwater exploration, whether they are geophysical methods or any geological methods are like remote sensing, GIS, okay, in geophysical methods, especially resistivity and seismic, and in geological methods and geobotanical methods. So these are the type of methods which are helpful in the groundwater exploration or in the identification of groundwater potential zones in the water scarcity zones. Okay. Here you can observe in the picture itself, it's showing the borewell drilling. Okay, borewell drilling, which is successful borewell drilling. Okay. So here you can see groundwater occurrence and aquifers. Okay. How groundwater occurs and what are the aquifers? What is aquifer? Is there any difference in aquifer system and what are the aquifer properties? Just we'll go through it. Okay. And groundwater is a found in permeable geological formation known as aquifers. Okay. Groundwater is found in permeable geological formation known as aquifer. Aquifer is a geological formation which may hold and transmit groundwater or which may store or transmit groundwater. Okay, that is called as a aquifer. A geological formation which may hold and transmit groundwater is called as aquifer. And aquifers include unconsolidated rocks, clastic sedimentary rocks, volcanic rocks, and crystalline rocks. Any rock can act as a aquifer, but it should have some properties like porosity and permeability, means holding capacity and transfer capacity or transmissivity. Okay. A geological formation which is having these properties can called as a aquifer. So aquifer geological formations like unconsolidated rocks, any clastic sedimentary rocks or volcanic rocks or crystalline rocks, we can call as aquifer. Intersects within aquifers such as capillary, subcapillary, and supercapillary spaces enable groundwater movement. Okay, here you can observe aquifers and wells. This is the unconfined aquifer. This is unconfined aquifer, and this is the water table. This is the water table in the unconfined aquifer, and this is the confined aquifer. Okay, confined aquifer is sandwiched between two unpermeable, okay, two impermeable layers, okay, like clay zone, okay, some clay layers will be there, and this confined aquifer sandwiched between two clay layers are impermeable layers. Okay, here you can see this is the water level. This is the water level of the confined aquifer. This is the water level of the confined aquifer. And this is the water level of the unconfined aquifer. Okay. So this is flowing well because this borewell drilled in the confined aquifer and it is water level is or this is borewell surface is lesser than the borewell surface is lesser than the actual confined aquifer water table. And so you're at the top of the confined aquifer. This is the top of the confined aquifer, unconfined aquifer. This is the open well. Okay. This is the artesian well. Sorry. Okay. Or flowing well. Okay. This is the artesian well. Okay. Next, distribution of groundwater in geological formation. In any geological formation, how groundwater will be distributed. Okay. Here you can observe this is the surface of the earth. This is the surface of the earth. Okay. Here one borewell drilled. And this is the unsaturated zone. As per our yesterday discussion, yesterday presentation, this is called unsaturated zone. Unsaturated zone means in a zone which is having water and water molecules and air molecules or water and air in the pore spaces. Means it is not fully saturated with the groundwater. It is called as a unsaturated. Saturated means a rock formation or any geological formation, it is filled or that rock formation pore spaces are filled with water only, not air gaps. Okay. Pore spaces are filled with or saturated with water. So it is called as saturated zone. Okay, this is unsaturated and this is the saturated zone. Difference is the pore spaces present in the this rock formation is filled with water and air. Whereas in saturated zone, these pore spaces are these pore spaces are filled with water. Okay, fully saturated. So this is the water table. Okay. Upper surface of the saturated zone called as the water table. Okay. A groundwater occurs various across geological formations. Aquifer types include alluvial valleys, tectonic valleys, abundant or buried valleys, and abundant and abundant and extensive plains with unconsolidated sediments. Groundwater in lithifield, sedimentary, volcanic, crystalline, and metamorphic rocks contributes to water resources. Okay. Next, methods of geological exploration. In groundwater exploration, first we will discuss about the geological exploration methods. Various methods are employed for geological exploration, including aerial photographs, structural analysis, geomorphological studies, well inventory, geological mapping, test drilling, geological logging, and test pits, adits, auger drilling, and continuous cone penetrometer. Okay, these are the exploration methods which are comes under the geological. Okay, and each method aids in assessing groundwater potential and contributes to the effective management. And this is the groundwater potential zones map. Okay, this is the and these are the highlighted. These are the blue color highlighted. These are the excellent potential zones. This zone is called as excellent groundwater potential zone. And this pink or red color low potential zone. This is the low potential zone. Okay, and the green color is the moderate to potential zone. Okay, moderate potential zones. So our target is this is the excellent potential zone or good potential zone. The light blue and the dark blue is our target in groundwater exploration. This is called as a groundwater potential zone mapping or thematic map of the groundwater potential zones. Based on this map, we can go directly and in this area or targeted this area, we can target and we'll get the groundwater potential zones in the drilling process. Okay. Next, geophysical. Just you try to read and try to observe all the images. Okay. This is the geophysical exploration for groundwater. Okay. Groundwater geophysical exploration method. Okay. Here you can observe. This also you can observe electric resistivity methods and electrode configuration, sound curves and curve matching. Just you try to read it. So geophysical exploration method, I hope you have read and written all the notes. Okay. Geophysical methods are crucial for uncovering subsurface secrets. Okay. Uncovering subsurface. Importance includes locating aquifers, estimating depths, and identifying geological structures. Overview of gravity, magnetic, seismic, and electrical methods with emphasis on electrical for groundwater studies. An explanation of groundwater movement in rocks under pressure gradients. Okay, these are the geophysical exploration procedure and possibilities and okay benefits from the geophysical methods. Okay, and here you can observe this is the geophysical. Okay, this is the geophysical log of the borewell. Okay, this is the geophysical log of the borewell. So resistivity, okay, susceptibility, conductivity, and gamma. These are the different type of logs which are done in the existing borewell. Okay, which are conducted in the existing borewell, and this is the related. Okay, this is the related subsurface formation details like casing, okay, and sphalerite, spar rock, and bedrock. These are the different type of rock formations, okay, and this is the groundwater. So groundwater existed from this, okay. After 5 meters of groundwater is identified. This is the after around 4 to 5 meters it is identified, okay. Based on gamma, conductivity, resistivity, susceptibility, and geological cross sections. And here you can see this is the resistivity meter or multi-electro resistivity imaging meter. Okay, and this is the pseudo section of the or resistivity data, multi-electrode resistivity data interpretation pseudo section or image of the subsurface. Okay, here this color indicates the hard rock, and the highlighted blue color is indicate the low resistivity or high conductivity zone in the subsurface of the earth. Okay, and here you can observe electrical resistivity methods title electrodes, currents and resistivity. And electricity resistivity methods is fundamental in groundwater exploration. Resistivity defined as a material resistance to the electrical current flow. Resistivity called as a material's resistance to the electrical current flow. When we apply a current flow to the any geological rock formation, the resistance will be noted. So these resistance and the geo geometric factor of the geological rock formation called, and when we apply the geometrical factor, okay, when we apply this geometrical factor to the resistance of the particular material, then we call as the resistivity of the rock formation, any geological rock formation. So resistance, when we apply the geometrical factor, then it is called as resistivity. So normally in resistivity methods, we will collect only resistance data. That resistance data will apply AB by 2 or any geometrical factor, then it is called as a resistivity. So, okay. And setup involves these resistivity electrode method involves 4 electrodes and calculation of apparent resistivity. Whatever data we collect in the field is called as apparent resistivity. So, apparent resistivity, the total resistivity of the rock formation, different type of rock formations and electrodes and all. Okay. So, when we will apply this apparent resistivity to the master curves, when we match with master curves, when we plot on the master curves data, then it is called as true resistivity. So what we will collect in the field itself, we will collect only apparent resistivity. Will convert it into, by applying master curve data, it is converted into true resistivity. So you try to read and write some definition. Okay, I hope you have written these definitions. Okay, now electrical configuration and sounding curves. Title: Configuration and Curves. Okay, detailed explanation of two electrode array and dipole array configurations. Sounding curves reflect geological structures and resistivity variations. Visual representation of the and visual representation of Venner array setup with the equi-spaced point electrodes and illustration of typical sounding curves during geophysical exploration. Curve matching techniques. Insight into direct and partial curve matching techniques for resistivity interpretation. Interpretation of 2 layers, 3 layers, and 4 layers field curves using master curves and auxiliary charts. Okay. Demonstration of interpretation through practical example. So what we'll do, just you try to read it and write down. What we'll do, normally we go for some agriculture area, whatever interested area. There we will install 4 electrodes resistivity method, okay, and we'll go for Venner or Schlumberger method, okay. Whatever method we follow, just we will install all 4 electrodes, 2 current electrodes, 2 potential electrodes, okay. The current and 2 potential electrodes after installation will take some data, okay, by applying current to the subsurface of the earth or geological rock formation of the earth, okay. Then we'll get some current and potential data. Okay. Okay. We'll get some potential data. Then we will apply potential factor, potential data, okay, and geometrical data or geofactor data will apply. Then we'll get to some resistivity. It is called as apparent resistivity. So this apparent resistivity, when we apply or when we matching with the master curves, which are existed, okay, master curves will be there. So to the existing master curves, we will match our collected data curves. Okay. When it is matching with some existing master curves, it is called as a true resistivity curves. So in the interpretation, we'll get some 2 layer, 3 layer, or 4 layer curves. Okay. Based on curves, what we get and we'll match with master curves. Then we call as A type or K type. Okay. Q type or H type. Majorly 4 types are there. So which type data or curve data we are getting and which is the formation, whether it is related to the formation or not, we should able to identify. We should have some knowledge regarding geological formation or stratigraphical or geological or rock type information we should have to the particular location. Okay. Then based on geological data or observation topographical or geomorphological data and resistivity data, we'll prepare the groundwater potential zones. Okay. Here you can observe electrical resistivity tomography and data processing. Title: Behind the Surface, Electrical Resistivity Tomography, Overview of ERT. Okay. As a cutting-edge subsurface imaging technique, exploration of setup with multi-electrode arrangement and data acquisition system, interpretation importance of precious data collection and processing for capturing resistivity variations, introduction to resistivity software for generating resistivity pseudo sections and inverse model resistivity methods. Okay, what we are discussing in this slide is in electrical resistivity tomography or data processing. In normal Wenner or Schlumberger resistivity method, will have four electrodes. Two are current electrodes and two are potential electrodes. So whatever data we collect, we'll get vertical in only single point. In the single location, we'll get vertical data of the different rock types or different rock layers which are present in the subsurface of the earth. Okay. But in this ERT method, number of electrodes is increased. Number of potential and number of current electrodes will be increased. For example, 24 electrodes, 48 electrodes, like we can extend till our requirement. Okay. So in this method, normally in VES, vertical electrical sounding resistivity method, we will get only point data or single location data, single location subsurface vertical data we will get. Whereas in ERT, okay, electrical resistivity tomography method, will get number of resistivity locations data in single task. Okay, so in all these 48 electrodes are 24 electrodes data. Okay, locations data we will collect and the same time we will interpret it in the system and it will give some image subsurface of the particular location it will give. By matching all the resistivity, all the electrodes data, it will match and it will give the continue profile data called as pseudo section or pseudo section of the geological rock formation data or subsurface data of the particular locations. It is called as pseudo section. Here you can see this is the pseudo section of the 48 electrodes. Okay. So here in resistivity, what will happen? Only single data, single location data we will get. Whereas in whereas in this ERT will get number of locations data. Okay. And all locations data will match and it will generate some pseudo section based on all resistivity values. So in a single time, in a single task, we'll get a number of locations data as a subsurface cross section. Okay. Here you can observe this is the potential zone and this is the hard rock. Okay. And you can observe this is the potential zone or low resistivity zone. Here also you can top up the layer showing the low resistivity. But when we are going to the deeper, it is showing hard rocks. Okay. This is the hard rock zone. So here you can observe. Okay, resistivity data and this is the distance. Okay, this is the horizontal resistivity in ohm meters and this is the depth. Okay, this is the resistivity. This is the numbers or colors differentiation you can observe here. This is the resistivity data of the different layers. Okay, 1 minute. So here again 51 to 11,498 resistivity is there. Okay. So this is the 51 and this is the 11,498 resistivity. So this is the different color showing the resistivity data minimum to maximum. And this is the depth data. Okay. Up to 230 meters. Okay. Or this is the horizontal distance. Okay. What you have collected number of vertical electrical data or number of electrodes data we have collected in the same location. Okay, and these are the different type of major curves. Okay, and this is the formula of the resistivity, Schlumberger array and Werner array. Okay, and here you can see this is the Schlumberger and Werner array. Here you can see resistivity equal to 2 pi a means this is the geometric factor. okay, or AB by 2, or distance factor, or geological factor, or rock formation factor. Okay, and V is the potential and I is the current. So when we give these values in resistivity surveys, normally we'll get V and I value. Okay, and when we apply this K factor or geometric factor, then we will get the resistivity of the particular area. And you can observe these are the different type of seismic waves, like seismic wave types, refraction and reflection. Okay, and these are the body waves and these are the surface waves. Okay, understanding the wave behavior, seismic waves plays a vital role in the uncovering subsurface structures. Body waves, compressional and waves, shear waves or S waves or P waves we can call, and surface waves like linear and waves and low waves. Okay, and next reflection or refraction title, disappearing subsurface signatures, reflection coefficient influences wave amplitude and material boundaries, and refraction coefficient describes angular deviation and material boundaries. Understanding critical angles in crucial in seismic refraction service. So these are the refraction survey method where we are giving some disturbances by artificially by hammering. Okay, and it will create some specific waves and a refraction will be noted. Okay, here we'll install all the geophones. Okay, and seismograph will be installed in the particular location. When we apply some force or when we apply some hammering or when we apply some energy by hammering, it will give some seismic waves, and geophones and seismograph will be recorded of the particular location. And here you can see, and these are the different types of the remote sensing and GIS applications. And you can see, and the title fundamentals of remote sensing and GIS. Remote sensing collects information without physical contact. We know, okay, remote sensing means a collection of data or collection of data information without physical contact. And GIS assembles, stores, manipulates, and displays geographical referenced information. Whatever data we have collected with geographical referenced information like latitude and longitude, it will plot the data and it will stores data and it will manipulates data and it will display some thematic maps of the particular data given in the of the particular location based on longs, longitude and latitude. Okay. A purpose includes identifying groundwater features and analyzing hydrogeomorphology. So based on this remote sensing data collection with latitude and longitude or location information, when we apply in the GIS software, okay, it will generate some thematic maps based on our data and its latitude, longitude, locations. So when we apply these, any data which is related to the groundwater potential zones, it will create some groundwater potential zones thematic maps like we have seen in previous sections. Okay, this like this we can generate thematic maps of the groundwater potential zones. So then it is easy to uh, drill in the potential zone area. This is the main applications or uses of the GIS and remote sensing and resistivity data collection. Here you can see this is the groundwater potential zone, which is having very good to poor groundwater. Here you can see this zone is having high groundwater potential zones, whereas in this zone, western side, uh, poor groundwater potential zones are identified based on generated groundwater potential zones of GIS software based on our input data like latitude, longitude, and resistivity and streams order, okay, and elevation data and existing borewells data and water levels data, existing water level data, graphical or geological rock formations data. So all data it will take as input and it will generate groundwater potential zones. So in this generating groundwater potential zones activity, we should apply elevation data, okay, existing groundwater table data, okay, any resistivity data, okay, and streams ordering data, lineaments data, any fractures data, geological rock formations data, okay, and rainfall data, infiltration data, runoff data, all data we should give as a input, and finally it will generate a thematic map of groundwater potential zone. This is the use of different type of geological, geophysical, and these seismic and GIS and remote scenes methods. Okay, these are which are helpful in the groundwater exploration. And next we'll go for the we'll try to cover this groundwater contamination. Okay, we'll try to cover groundwater contamination, that is block 4, block 3. Okay, and landfill. Here you can observe in this picture, these are the landfills by human activities. Okay, and you can observe these are the landfills. These are the landfills. Okay, seepage from the landfills, which is contaminating in the groundwater. And you see here, these are the existing wells, and it will also contaminate the existing well, and polluted water will use, okay, for domestic purpose, whatever. And here you can see septic tanks also, due to the leakage of septic tanks, some seepage will be there, and again it will contaminate the groundwater, existing groundwater or existing aquifer system, and then it will connect to the bore wells. And here you can observe different type of pesticides and fertilizers which are presented in the streams and nearby streams or banks of the rivers, and it will go as a runoff and it will join in the some oceans, okay, or it will join in the major river system, and that also will that also gives some pollution or seepage leakage to the aquifer system. Then this aquifer system is connected with bore wells, and the bore wells water, whatever water we will collect from bore wells, will use for the drinking purpose or any agriculture activity or domestic purpose. Okay, this is the entire pollution system or groundwater contamination activity through the different type of process or different type of activities like pesticides, fertilizers from streams or runoff, and septic tank leakages from domestic areas, and seepage from the landfills or wastage fills in the dumping yards. So all are and will uh, act as a pollutants, and it will contaminate the groundwater resources. So quality of groundwater will discuss, water pollution and seawater intrusion and control methods will discuss in the presentation. Here you can see introduction to the groundwater quality. So groundwater quality is influenced by various factors, including dissolved chemicals, contaminants from industrial, domestic and agricultural sources, and bacterial contamination. And chlorination is commonly used to address bacterial contamination. When we identify the bacterial contamination is in drinking water, we go for the chlorination process, okay, to remove the bacterial contamination. And physical properties, parameters of groundwaters like such as color, odor, taste, turbidity, and temperature plays a crucial role in determining groundwater quality. And these parameters are measured using specific units to assess the suitability of groundwater for various uses. Chemical parameters of groundwater chemical parameters. These are the physical parameters. What are the physical parameters? Color, odor, taste, turbidity, and temperature are the physical parameters of the groundwater. What are the chemical parameters? Major ions, like chemical parameters like pH, TDS, total alkalinity, total hardness, and various ions determines in the chemical composition of groundwater. Various ions means major ions: calcium, magnesium, potassium, cations, and anions. Calcium, magnesium, potassium, sulfate, nitrate, like calcium carbonate, fluoride. These are the major ions. Major ions chemical constituents including cations and anions as well as dissolved gases and trace elements impact groundwater quality. These are the different type of quality measurements, physical parameters and chemical parameters, which are useful in the, which are plays a crucial role in the groundwater quality estimation or groundwater quality assessment. And you can see here water classification based on classification of groundwater based on TDS, total dissolved solids. Okay. Groundwater is classified based on its total dissolved solids. Groundwater is classified based on the total dissolved solids concentration into categories such as fresh water, brackish water, salty water, and brine water. The TDS concentration ranges vary each type of groundwater. Major chemical constituents, Major chemical constituents of groundwater. Groundwater contains various major chemical constituents including calcium, magnesium, sodium, potassium, carbonate, bicarbonate, chloride, sulfate, nitrate, and fluoride. So each constituent has specific source and effects on groundwater quality. These are the major quality or major chemical constituents, okay, which are present in the analysis part. Okay, or water classification. Biological impurities like biological impurities in groundwater, bacteria and microorganisms present in groundwater can indicate potential contamination with coliform serving as an indicator of pathogenic bacteria and biochemical oxygen demand. BOD is used to assess the presence of organic matter in the groundwater. These are the major methods BOD. Okay, and contamination with coliform several serve as serving as a indicator of pathogenic bacteria. Okay, BOD and its nitro nitrogenous stage, like all biological impurities will identify in the groundwater quality assessment method. And environmental impact on human health. Here you can see these are the best example image like headache and fatigue because of CO and ozone, SiO2 and volatile organic compounds, and these are because of this air pollution and all. Okay. And whereas see bacterial parasites and chemicals also give headache and fatigue to the human body, and soil contamination like pesticides and fertilizers. Okay. And bacterial respiratory illness will give cardiovascular illness and gastroenteritis and cancer risk. These are the uh, problems which are coming because of pesticides. Okay. So these are the, because of air pollution, we'll get this type of health issues. Because of water pollution, we'll get to this type of digestion system issues. And because of the soil contamination and soil pollution, we'll get cancer risk or skin irritation issues in the human body. Okay. And impact on irrigation and industry. Groundwater quality also affects irrigation lands and industrial process. Parameters like TDS, SAR, sodium absorption ratio, chloride, boron, sulfate, and bicarbonate influences sustainability for irrigation, and salinity hazard increase with fine-grained soils and aridity, affecting soil quality and crop growth. Crops exhibit varying tolerance to salt concentration. High sodium content in water can decrease soil permeability, requiring special management practices. And groundwater quality criteria for industrial purpose vary with parameters like salinity, total hardness, and silica being crucial. And each industry may have its own recommended limits or ranges for water quality parameters. Okay. And each industry, it should have some ETPs and treatment systems. Okay. And this is the treatment of groundwater. Purpose of treatment is how we will treat the groundwater, and purpose of treatment ensures water is potable for public supply schemes. Some mineral presence is essential for taste and food assimilation, but excessive dissolved content constituents can cause health hazards. Okay, and treatment methods: sedimentation removes inorganic impurities through settling tanks. The sedimentation method, and coagulation increases particle size using chemical like aluminum sulfate, converting them into set, settleable size, and filtration, disinfection, elimination remaining impurities like bacteria, dissolved salts, color, odor, and taste through methods like chlorinization, and water softening. Softens water by removing temporary or permanent hardness using methods like boiling, lime soda, geolite, or demineralization processes. These are the different type of treatments of groundwater quality related issues. And environmental impact. Groundwater quality parameters. Physical parameters include color, odor, taste, turbidity, and temperature, indicating pollution sources and mineral presence. Whereas chemical parameters comprise pH, TDS, alkalinity, hardness, various ions, dissolved gases, and trace elements influences health risks and environmental problems. Okay, and environmental evolution like based on groundwater quality for drinking, irrigation, and industrial purpose with specific standards for various elements, the environmental evolution will be done. And treatment importance essential for ensuring portability and removing excess salts or elements that could lead to health issues or environmental degradation. And unit 4 is the water pollution. Effects of water pollution. Waterborne diseases, contaminated water sources can transmit diseases such as dysentery, typhoid fever, and cholera, and hepatitis caused by pathogens like viruses and bacteria and parasites. Environmental impact like water pollution poses threats to ecosystems, leading to the destruction of plants and animals' life and aesthetic degradation. It also affects drinking water sources and aquatic biodiversity. And types of water pollution. Domestic water pollution mainly caused by sewage discharge. Domestic water pollution includes human excreta, detergents, and other waste materials. It contributes to the entropic eutrophication of water bodies. Industrial pollution, like industrial effluents, contain harmful substances like oils, plastics, heavy metals, and acids, adversely affecting water quality and aquatic life. And agriculture water pollution, irrigation practices contributes to water pollution by contaminating organic salts in soil and drainage water, affecting soil fertility and crop productivity. And soil waste pollution, improper disposal of solid waste leads to contamination of water source and soil, causing health risk to human and wildlife. So these are the different type of pollutions which are related to the groundwater or groundwater water quality mainly for drinking and irrigation and domestic purpose. See, air pollution leaches into the rainwater. Okay, and improper drug disposals and animal waste. gasoline leaks, sewage of the and agriculture runoff, animal waste, manufacturing of plant waste. These are the different sources of the groundwater pollution. Okay, water pollution in India, extent of pollution, major rivers in India, crucial crucial for drinking water supply and agriculture suffer severe contamination due to the industrial and domestic waste. Approximately 70% of water bodies are polluted, with the 74% of highly polluting industrial discharging toxic effluents. Important on health and environment. Pollution leads to the destruction of aquatic life, health risk from contaminated water resources, and challenges in water treatment. The Ganga, Yamuna, and other rivers face significant pollution due to the industrial and domestic waste discharge. Source of groundwater pollution. Natural sources like arsenic and fluoride. Here you can see arsenic and fluoride contamination in groundwater can occur can occur naturally due to the geological processes impacting water quality and posing health risks, particularly to regions like Bangladesh and West Bengal. Urban disposals, sewage leakage, liquid waste discharge, and soil waste discharge, contamination to the groundwater pollution, leakage from sewer system, improper disposal of liquid and solid waste and landfills are a significant source of the contamination of groundwater. Okay. And industrial discharges like industrial release various pollutants into the groundwater through liquid waste discharge, tank and pipeline leakage, mining activities, and oil field brains, heavy metals, acids, organic compounds from industrial processes contribute to groundwater pollution, causing environmental and health hazards. And here you can observe these are the different type of the pesticides and which are useful or which are using in the agriculture activity which may cause the groundwater pollution. Okay, irrigation, return flow, and animal waste, fertilizer and soil amendments, pesticides. These are the different type of agriculture sources. These are the different type of agriculture sources of groundwater contamination. Okay. Just here you can observe the unit 9 seawater intrusion and control methods. Okay. What is the seawater intrusion? Controlling seawater intrusion, water intrusion definition, controlling methods, and Gaibin-Herberg relation. What is the relation between this seawater and this freshwater? Okay. And groundwater recharge. Groundwater recharge also very good and uh, ground recharge, rainfall, runoff, irrigation, return flow. These are when these are in sufficient amounts, the groundwater recharge will be good, but it should not be contaminated. These rainfall, runoff, or irrigation, return flows, it should not be contaminated with the effluents or sewage or any leakages from industrial or any agriculture activities. Okay. And for groundwater recharge, we should encourage artificial recharge methods like flooding, water spreading, injection wells, utilizing excess surface water, controlled releases, and rainwater harvesting methods. Okay. And root water harvesting methods. And different type of methods or structures which are involved in the rainwater harvesting. We should encourage and we should give aware to the public. Importance of sustainable management. Balance extraction with recharge and prevent adverse effective intrusion and subsidence. Okay. So when we use 1 liter of water, we should able to recharge 1 liter of water with a different type of recharge rainwater harvesting techniques. When we use 100 liters of water, we should able to recharge 100 liter of water to the rainwater harvesting artificial structures. Okay. And here you can observe this is the groundwater management system. Okay. water zone, recharge basins. Okay, and these are different type of the streamed and recharge recovery, groundwater management strategies and practices, concepts of groundwater management, equation of gradual equivalent. These are the different types of groundwater management challenges and methods. Okay, so I hope you understood and try to read, try to watch number of times. Okay. And groundwater exploration, groundwater contamination, or groundwater management, what is groundwater, what is hydrogeology. We have discussed it in last the presentation and today presentation. Okay, so we should able to remember the keywords like when we write about hydrological cycle, we should able to remember all the main processes like evaporation, okay, con, evaporation and cloud forming, okay, condensation and precipitation, infiltration, runoff, like that we should able to remember. Then only we can write theory exams easily. Okay, thank you, and I hope you understood.